Hello, in this video we will solve the integration of 1 over e to the power x bracket 1 plus e to the power x dx. The first step to do is to expand the denominator. So after expanding the denominator, we have the integral of 1 over e to the power x plus e to the power of 2x dx. Following which I will multiply the numerator by e to the power x as well as the denominator by e to the power x. Alright, and then this is the term after multiplying e to the power x by e to the power x. Okay, and then I will expand the denominator once more. So I will have integral of e to the power x over e to the power 2x plus e to the power 3x dx. Following which, I will use the integration technique, one integration technique which is called integration by substitution. Integration by substitution. Okay, and then we let EU be equals to e to the power x, and we differentiate u with respect to x. This gives us e to the power x, and then when we multiply both sides by dx, we'll get du is equals to e to the power of x dx. Okay, so if you were to focus on the question, so the numerator would be my du after doing the change of variables, and then my denominator would be u squared and u cubed, u squared plus u cubed. Rewriting this, that will just be equals to the integral of du over u squared plus u cubed, which can also be rewritten as the integral of du over u squared bracket 1 plus u by factoring out the u squared. Next, we will perform the partial fraction. So how do we do the partial fraction? If we were to look at here, we have a linear term and then we have a quadratic term. So it can be also expressed as follows. 1 over u squared 1 plus u is equivalent to a plus so a over 1 plus u plus b over u plus c over u squared. And then when we multiply both sides by the u 1 plus u, so we get 1, which is equals to big A, right? U squared plus big B, u 1 plus u, and then we have plus c, which is 1 plus u. Alright, and then what we do is when we let u be equals to -1. So when u is equal to -1, this term is the second term is disappeared, the third term is disappeared, so we left with 1 is equals to a -1 square, in which this is also, in other words, it means that a is equivalent to 1. Okay, a is equivalent to 1. Okay, so when so we need to find basically b and c constant after we found a constant, which is equals to 1. When u is equals to 0, we can find constant c actually. So because when u is equals to 0, my first term is 0, my second term is also 0, so in which my last term is just c. So c is also equals to 1. And then with the help of the constant a and constant c, after we found them, we can actually find b. So we let if u is equals to 1, and then we know that this is equals to 1 is equals to, so basically what we are doing is that we are using this statement. So it's 1 is equals to a, which is 1, and then u square is just -1 square plus b, which is unknown, and u is just 1, and 1 plus 1 is 2, plus c, basically c is just 1, and 1 plus 1, which is 2. Okay, so we have as follows: 1 is equals to 1 times negative 1 square, plus b times 1 times 2 plus 1 times 2. Alright, so if you have to rearrange this, we will get negative 2 is equals to 2b, and b is equals to negative 1. So in other words, 1 over u square bracket 1 plus u is equals to 1 over 1 plus u minus 1 over u plus 1 over u square. Okay, just to rewrite this, this is equivalent to the integral of, let's put square bracket down here. So we have 1 over 1 plus u, subtracting away 1 over u plus 1 over u square du. Alright, we can split this up into 3 integrals, in which each integral will contain 1 fraction. So the first integral will be the integral of 1 over 1 plus u, okay, du. While the second integral will be integral of 1 over u du, while the last integral will be 1 over u squared du. Alright, and I'm gonna just erase a bit because we do not have space. Let's see if we can, try and continue down here. Okay, so basically, as you can see, what we do just now is we use partial fractions to break down, what we call decompose, the fractions into 3 different fractions. All right. After which, we can proceed to do the integration. So the first term after integration will be ln absolute 1 plus u, while the second one would just be ln absolute u, and the last one will be minus 1 over u plus c. Alright, so this is actually u, alright, u, okay, 1 plus u, okay. Okay, last but not least, because we do a change of variables just now from x to u, we have to change it back. So we substitute u as e to the power x. So in this sentence, what we are doing is that we are switching back to the x variable, because that is what the question originally asked in terms of x. So there will be ln absolute 1 plus e to the power x, subtracting away the ln absolute e to the power x minus 1 over e to the power x plus c. Well, the second term can be simplified as just x, because you can bring the x down, and ln e is basically just 1. Okay, so it's just 9 minus x. And then the first term and the third term, we will keep it as it is. So the final answer to the equation of 1 over e to the power x, 1 plus e to the power x dx is ln absolute 1 plus e to the power x minus away x minus 1 over e to the power x plus c. So if you guys do like this solution, press the like button. Don't forget to subscribe to support my channel. Thank you guys for watching, and I will see you in the next video.